Hey guys, let's get started with today's review. As I'm going through this, again, I'm going to work through the ones that we did in class plus the other ones. Okay, so what I'm going to do, for those of you that are here because you've already seen the video, or I'm sorry, you're seeing the notes in class, I'm going to go ahead and do the ones that we didn't do in class first. All right, so the first one that we did not do was number 2. Now on this one's here, there is no distribution happening. It is an expression, no equation. So we are just going to combine like terms. Okay. So we have 12c and negative 2c. Those two there will come out to 10c. Then we have negative 3 and negative 13 are both constant terms. So that gives me negative 16, okay? All right, now to number 4. On number 4, the first thing we have to do when we're looking at this, remember this is an equation, okay? And we want to look for that distribution if there is any. Simplify the left side, simplify the right side, that kind of stuff. So if I'm just looking at the left side of the equation first, is there anything there that I can do? Well, yes, I can combine like terms. I can combine 2x with negative 4x. So we're going to simplify this side. So that'll be negative 2x plus 5. Okay. On the right side, I can simplify by doing distribution. So 3 times 1 is 3, and 3 times negative x is negative 3x. Okay. Now that we've simplified, we want to get all our x's to one side. We want to try to get all our variable terms together. Keep in mind that we like to take the one that is the smaller value, the smallest value with x. So when I'm looking at this, I have a negative 2x and a negative 3x. The smallest of those two is the negative 3x because that is smaller than negative 2. Okay. So let's go ahead and take the negative 3x, and instead of having it on the left side, we're going to move it to the right side. Okay, so I'm going to add 3x to both sides. Now, if you feel comfortable not showing this step, like actually adding it, you can do that. Negative 2x plus 3x, well, that makes 1x, which is just x, plus 5 is equal to 3. These two here, we don't need anymore because they actually just simplify to 0. Now, I have to move the 5 to the opposite side to get it away from x. So the opposite of 5 would be subtracting 5 from the right side of the equation. So I have x equals negative 2. Remember that these end up canceling out. There's nothing left there. They equal 0. Okay? All right, number 6 is y equals mx plus b, and they want us to solve for x. So let's draw our line to show that it's an equal. If I'm trying to get x by itself, x is currently part of that term, so I want to get rid of this guy, okay, because it has nothing to do with that term. I want to undo addition and subtraction first. So instead of adding b to the right side, we are going to subtract b from the left side. Okay. Now, still have to get x by itself, so what's happening between the m and the x? Well, they're being multiplied. So instead of multiplying on the right side, we're going to get rid of that, and we're going to divide on the left side. Okay. This answer is correct, where you have y minus b over m equals x. But we also talked about it as everything can be divided by m. Okay, so either of those two answers would be correct. All right. Okay, let's see. Number 7, number 8, number 9. All right, so let's go down to number 9. This is the last one that we did not do in class. We did create a table, or we started to. We have a table there. Now, I want you on your table to always pick 5 magic numbers. And those magic numbers, I always start with 0. And then I pick -1, -2, 1, and 2. And you have one extra box on the bottom, so go ahead and use that box, which is 3. Okay. So what we're going to do is we're going to plug values into our equation. I'm just making my boxes like you have yours. So it kind of resembles what you have. Okay. So we are going to take this equation and we are going to substitute in the x values. If you remember substitution, we're circling back to what we did before. Okay, we're going to take -2. So have y equals the absolute value of -2 minus 1 minus 3. And I'm actually going to put those absolute values a little bit different color because I don't want you to think they're 1s. Okay, so those are my absolute value bars there. All right, so with that, I have y equals the absolute value of -3 minus 3. Okay. The absolute value of -3 is always going to, whenever you have these absolute values, whatever number is in there, when you take that value out, it's going to be a positive number because it's always the distance away from 0, okay? So -3 is 3 spaces away from 0. So this one here would be 3 minus 3, which comes out to 0. So when we substituted in -2, we got 0 for our y value. Okay. Now let's go over and plot that. So -2, 0 is right here. All right, now we're going to do it again, but this time, instead of -2, we're going to substitute in -1. So we have y equals -1, the absolute value of that, of -1 minus 1 minus 3. So then we have y equals the absolute value of -2 minus 3. Sorry, that minus 3 should be in black. Okay. That comes out to y equals the absolute value of -2 is 2 because it's 2 spots away from 0. 2 minus 3, which is y equals -1. So whenever we substituted in -1, we got out -1. Okay. So let's go over and graph that. X is -1, y is -1. Okay. All right, do the same thing with 0. So we've got y equals the absolute value of 0 minus 1 minus 3. So we have y equals 0 minus 1 is -1 minus 3. So we have y equals 1 minus 3, and y is equal to negative 2. 0, negative 2. 0, negative 2. Okay. Now we've got 3 more values to check that with. Okay, I'm going to leave those 3 for you to check yourself. All right, so that you guys can do the math. I will tell you what those answers are, but I do want you to go back and figure those out yourself. Okay, so let's see. If I was to substitute in 1, I would get out negative 3. Okay. If I was to substitute in 2, it's 1, I would get negative 2. And if I was to substitute in 3, I'd get negative 1. Okay, so once I graph those 6 values, so 1, negative 3, and 2, negative 2, and 3, negative 1. All right, when I'm looking at my graph here, I can see that my graph really did start somewhere way up here, and it does go down, but once it hits that point there, it stops decreasing, and then it starts increasing. Okay, so it's like 2 linear equations put together. Okay, but 2 of them. So when I'm talking about the domain on this one, the domain is the x values. Well, the arrows tell me that it's going to keep going to the left. So the domain is going to be negative infinity to positive infinity. Okay. And the range, how low did this graph start, or how low does it go? Well, this graph doesn't go all very far. It only goes down to negative 3. So it starts at negative 3. Okay. But now instead of a parentheses, we're going to use a bracket. That tells us like it stops right there. I kind of think of that as like a brick wall. It stops, right? Parentheses means we can keep pushing it a little bit further and a little bit further. How high does it go though? Well, it keeps going to positive infinity. And since positive infinity can keep being pushed further and further, we put a parentheses around that one. All right, so I'm going to stop this video here. So for those of you that were in class today, you've got these ones here to look at, and I will send out my notes that I had on the board and remind. All right, talk to y'all later.